Welcome to Lab 3, Engineering 130. Inputs, which is the ABC, and the ABC is the temperature in the digital form. So whenever we want to use the temperature in the digital form for it, we didn't go through the numbering system yet, but we need 3 bits to indicate the numbers from 0 to 7. So the ABC is indicating the 3 inputs, and then it's going to be transferred somehow to a decimal form that we already know about, and it goes from 0 to 7. Now it's telling me that if the decimal value is 0, 1, or 2, then my indicator of the to called will be on. If it's 3 or 4, my indicator of the just right will be on. And if it's 5, 6, or 7, my indicator for the too hot will be on. So for these 3, it's going to be indicating that it is too cold whenever my temperature falls in that range. But this range is just going to be just right. So my just right will equal 1 only for these 2 possibilities. My too cold will equal 1 for those 3 possibilities. And my too hot will equal to 1 for those 3 possibilities. So in other words, when I'm building my truth table, one more here left. And then 0, 0, 1, 1. So now for the too cold, it's going to equal 1 at these 3 positions where the value is equal to 0, 1, or 2. In the just right, it's going to be 1 here. And in the cold, too hot, it's going to be those 3 here. Okay, so it means that all the other options are going to be zeros. Now to find the Boolean function expression for each one of them, so let's start with the too cold. Okay, I have 1, 2, 3 minterms. So for the too cold is equal to the first minterm here, which is the A complement, B complement, C complement, or A complement, B complement, C, or just erase complement C, or A complement, B, C complement. Okay. Now my second question is, can we simplify this even more? And the answer is yes, we can. So let's simplify this. So by looking at these 2, I have the A complement and the B complement as a common factor. So I can leave the C complement or C here. A complement, B, C complement. And therefore, we know that this is going to equal to 1. So I have A complement, B complement, or with A complement, B, C complement. Okay, now I can take the A complement as a common factor between those 2. So it will be A complement. We're going to have B complement or with the B, C complement. Now following the golden rule that says that any variable ORed with the complement of the variable that has been ANDed with a different variable is just going to be the 2 variables ORed together. So this one is going to be analysis for the complement. This is going to be the B, and this is going to be the C. So my X here, the one that's alone, is the B complement. So if you complement it again, you're going to get the B back, and then you have your Y is analogy to the C. So here my too called is just going to be the A complement, okay, B complement or C complement, or C, sorry. Oh yeah, that's C complement. Yeah, this is the C complement. So here, too cold at the end is equal to A complement, B complement, or A complement, C complement. Okay, and that is the final expression for the too cold. Now let's look for the just right. For the just right, I have only two midterms here, which is midterm number 3 and midterm number 4. So let's do the just right. That is midterm number 3 and midterm number 4. So this is going to be, let's try to write it down here. For the 3, it's going to be A complement BC, A, B complement, C complement. Now, by looking at this one here, asking the same question, can we simplify it or not? Can it simply be simplified even more? This is the just right. There's no common factors in between, so the answer is no, and it's just going to remain as is. Okay. Now, if we go back here to the too hot, we're going to notice that we have those 3 midterms, which is midterm number 5, 6, and 7. So let's go do those. So that's for the too hot. It's going to be midterm number 5, midterm number 6, and midterm number 7. So let me just put the ABCs there. So for the midterm 5 is 101, 6 is 110, and then the ABC. Now, can this one be simplified? Yes, because we have a lot of common factors there. So let's do, for me, let me take this one and this one first, okay? And you can do a different way. So I will take the AC as a common factor. So I'm going to end up having the B complement or B plus the A, B, C complement. Now this is going to equal 1. So it's going to end up having AC plus A, B, C complement. Now both of those have the A as a common factor. So I can have C plus C complement B. Now this is following the golden rule that says that any variable ORed with the complement of that variable that has been ANDed with another one is X or Y. So your X is going to be the C and your Y is going to be the B. And therefore, it's going to be A, C plus B, or in other words, your too hot output is going to be AC or AB. So those are the 3 equations for your 3 outputs of the system. So back here, we would like to implement those 3. So how to draw the schematic diagram? Actually, we have multiple ways. So for example, for the too cold was equal to A complement, C complement, or A complement, B complement. So I can plot it that way, or I can take the A complement as a common factor and put it in that form. So this is like, I'm going to call this form number 1, and this is going to be form number 2. So if you're going to be plotting that, drawing the schematic diagram, and therefore that's what you're going to be implementing on your breadboard, it can be the first form, like form number 1. So you're going to have an AND gate. Here you're going to have an inverter before that, for the A, B, and then, well, let me just switch those two. So it's easy to. So this is my B, this is my A, and again, you're going to have the inverter, so the A complement. Again, it's going to come here, and this is your C. So the output here is A complement, and it would be a complement. The output here is A complement, which is this part, and it with C complement. And then you're going to be ORing those 2 together. So that's one way to do it. Form number 2 is that I do it this way. So I'm going to have an OR gate. And we'll have here the B pass through an inverter first and then go to the OR gate. Okay. And then I have my A will be ANDed to the result later on. That's the AND. Okay, so both forms are okay. You can use whatever you feel more comfortable with. Letting you know that now for the too hot, it's equal to A, C, or A, B, and I can do it also as C or B. So it's the same concept, but I can have two AND gates. One of them is A and C, the other is A and B. Okay, so this is just the A. And then I have an OR gate that's connecting both of them. So that's going to be form number one. Now for number two, I can have the C ORed with the B, and then the result will be ANDed with the A, and I get my output of too hot. So any of the forms can be appropriate. Now for the, sure. Let me just add one more slide. Okay. And let's go back. So for just right, it was equal to A complement BC or A B complement, I'm sorry, C complement. Okay, so that means that there's two ways to do it. Either I can use one AND gate with three inputs. So this is a 3-input AND. It's going to have 3 inputs here. This is going to be the A, and then this is going to be the B, the C. And the other AND is just going to have the A as is, but it's going to be complementing the B and C before entering. And then you have the OR gate. Okay, so this is one way, which means that you need to include on your board a 3-input AND gate. Okay, go look up for the number for that one and find the 3-input AND gate. Now, if you don't want to use the 3-input AND gate and you just want to use the 2-input that you're used to, then I can implement it in this form. So I will have BC together. Okay, and also I will have the B complement and C complement ended together. Okay, and then, so this is the BC. Then I will end it again with an A, with an A complement. Okay. And for this one here, the B complement C, I will end it again with an A. And then I will take these two and OR them together to get my output. Now, the main difference between the two circuits is that here you're going to be using 4 AND gates. Okay, but here you're going to be using 2 AND gates, but the type of the AND gate is the 3-input one. Here, the type is the 2-input. Okay, now for the 3 inputs, sometimes when we're doing it on the breadboard, it will have problem that we're having power supplies that provide 5 volt. Sometimes it slightly needs more power than the 5. So some of you might encounter a problem of having the circuit work when you use the 3-input AND gate, but you can also give it a try. There's no problem. So I would suggest that you first build the two cold, the two hot, make sure that they work, and then you can add up the just right part. Okay. So let me just pause here and come back. Okay, so now here is the pins of your IC chips. So I'm gonna be building it, all of it, using the 2-input AND gate. Okay, So I have, here I have the not. And then here I have the AND gate. So I have two AND gates, this one and this one. So I put two of them. And then finally here I have the OR. So number one, I know that I need to find the inverter for all the inputs. So this one is going to be my A. This is going to be my A complement. This is going to be my B. This is going to be my B complement. This is going to be my C, and this is the output of the C complement. So these are the three inverters. You're going to take it from the three switches. Maybe use switch 1, 2, and 3. So switch 1 is going to be connected to the A, and your output here is A complement. Switch 2 is going to be connected to the B, and switch 3 is going to be connected to the C. Now let's build the two-pole circuit that says it is A, B, or AC. So I'm assuming that I'll be doing it on that form. Okay, and it's up to you if you want to use the other form. So if I'm using this one here, A, B, or AC, I will take here, this one will come for the A, and this is for the from the B. I just don't want to be connecting doing a lot of wires. So this is going to come from the A and B, and then you're going to have another one that's going to come from the A again and C. And then you're going to take the two outputs. So this is the first output, which is AB, and this is your second output, which is AC. Those are going to be the inputs to your OR gate. Okay, so I'm going to take this OR gate here. So this OR gate is going to have this output. That's the first one. And the second output. It's going to be the input to the OR gate. And now this is your 2-volt. So this is going to go to the lead. So one of your LEDs, it's going to go there. Now let's do the 2 hot. Probably I switch them. So this is the 2 hot. Okay, so that's going to be the 2 hot circuit. And then the 2 cold is going to be the ones with the complement. So it's A complement, B complement, or A complement, C complement. Okay, so the first one we built was the 2 hot. And now we're going to be building the 2 cold. So the 2 cold is, I'm going to be taking inputs from the A complement and the B complement. I can be using these 2 AND gates. So my first input here is coming from the A complement. My second input here is coming from the B complement. So my output here is the A complement, B complement. And then for my second input, my second AND gate, I'm going to put here the A complement and here the C complement. And the output here is the A complement, C complement. Okay. Now the A complement, C complement, the A complement, B complement, these are going to go to an OR gate. So maybe I can take this one that's on top here. These 2 are going to be the input to the OR gate. And then this is going to go to the panel where you have 2 cold. That's the 2 cold. It will go to the lead. Okay, so the output will go to the lead. So now you build the 2 hot and the 2 cold. Now let's build the just right. And that one is a little bit tricky. So I'm going to be building it using only, now I finished this AND gate. This one has been all filled up. So I will need to use the second one. For the second one, I will be using the 2 input AND gates. So if you remember, the plot for it is like I'm going to be doing ANDing the BC first and then AND it with an A. Okay, and then I will take the A complement, AND it with the B complement, C complement. So I'm going to be ANDing these 2 first and then AND it with the A and then OR them together. So I will take the B and C. I need to create the B and C. Sorry, let me look it up again. So it's A complement with the BC, and then it is A with the B complement, C complement. Okay. So I will take BC. So I'm going to use this AND gate. So this is going to come from the B. This is going to come from the C. okay? And then the output, I will take it to the next one, okay? That's the BC, and I will end it with the A complement. Now the output here is the A complement BC. Now I would do the same thing. So I use these two AND gates to cover this part only. Now I'm going to use the second two in the bottom to cover the other one. So I'm going to here take the B complement. So this is going to come from the B complement here. And this is going to come from the C complement. And get the output here, which is B complement, C complement, it's going to enter right away to the second AND gate and end it with the A. And then the output here is the A, B complement, C complement. Now I'm going to take these two big outputs here and pass them through an OR gate. You can use this one or this one. So I'm going to take them here, pass them to this OR gate. Oh, I think I messed up the. Okay. So pin number 4 and 5. So these are the two. And then this is your output to the just right left. So these are the 3 outputs and how you can connect them. So make sure that you connect the 2 hot and then the 2 cold. Make sure that they're working, and then you can move on to the just right.